Welcome to Chapter 15. In this chapter, we shift from collecting data to actually making sense of it. We'll look at how data are managed, how different statistical approaches help us answer evaluation questions, and finally, we'll look at how results get communicated through formal reports and presentations. This chapter gives you a full walkthrough of the data analysis process. We will talk about the steps in data management, look at examples of univariate, bivariate, and multivariate analyses, review the structure of a formal evaluation report, and go over best practices for presenting findings in ways that stakeholders can use. When you design an evaluation, you also need to plan out how the data will be analyzed. Different stakeholders care about different outcomes, and the type of data you collect determines which analyses make sense. Ultimately, analysis is what reveals whether your program had an impact and provides the basis for the conclusions you present. Before you can analyze anything, you need to manage the raw data. That means coding responses, cleaning errors, and organizing information so that it is usable. A code book guides the entire process, documenting each variable, how responses are coded, and what statistical tests are appropriate. Data cleaning ensures the integrity of the data set. When you are data cleaning, you are looking for missing responses, incorrect entries, and data that just does not make sense. In some cases, incomplete or indecipherable data may be discarded to keep the analysis valid. Data analysis starts with identifying the variables you are working with. Independent variables are the influences or conditions under which you control, while dependent variables represent the outcomes you are trying to affect. Choosing the right statistical approaches allows you to answer evaluation questions early. We use two major families of statistics. Descriptive statistics summarize what your sample looks like, things like averages, percentages, and distributions. Inferential statistics let you move beyond the sample to identify relationships, test differences, and draw conclusions about a larger population. Univariate analysis focuses on a single variable. For example, how many people enrolled in your program last month? Bivariate analysis looks at two variables at one time, allowing us to explore relationships and differences. It starts asking more interesting and meaningful questions. When two or more variables are involved, we move into multivariate analysis. This lets us explore complex relationships. For example, how education, income, and family size might collectively influence health outcomes. This slide gives you a practical example of a univariate analysis using temperature data. It shows how we can calculate frequency, mean, median, mode, and range, each one telling us something slightly different about the data set. These are basic statistics and are foundational for more advanced analysis. Statistical tests fall into two categories, parametric and non-parametric. Parametric tests make assumptions about the underlying data distribution, while non-parametric tests are more flexible when those assumptions are not met. Understanding the difference between these two can help you choose appropriate methods. When selecting an analysis method, several factors matter. What question you're trying to answer, the level of measurement for each variable, and whether you are using parametric or non-parametric tests, and finally, the type of information your audience wants to know. These choices shape the clarity and credibility of your findings. This summarizes the core univariate statistics, measures of frequency, central tendency, and spread. Tools like mean, median, mode, range, variance, and standard deviation help paint a clear picture of your sample before you move into more complex analysis. Bivariate analysis lets us test relationships and compare groups. Statistical significance helps determine whether the differences we observe are likely due to chance. In evaluation, significance levels of 0.01 or 0.05 are most commonly used to interpret the results. When testing evaluation questions, we start with hypotheses. The null hypothesis states there is no difference, while the alternative indicates that there is. Type 1 and Type 2 errors remind us that there is always a risk of misinterpreting the results, which is why careful analysis design is essential. Common bivariate tests include chi-square for categorical associations, t-test for comparing groups, and ANOVA when comparing 3 or more groups. Correlations show whether 2 variables move together, helping you understand patterns without assuming causality. For multivariate analysis, evaluators turn to techniques like multiple regression, discriminant analysis, and factor analysis. These methods help untangle complex relationships and identify which variables truly matter in predicting outcomes. This gives you an example of multivariate analysis in action, using multiple predictors to estimate heart disease risk. Practical significance here is also important. It reminds us that beyond statistical results, we need to consider what is meaningful and useful for stakeholders. Evaluation reports serve several important purposes. They document program planning, explain the results in context, highlight lessons learned, and demonstrate accountability to funders. The format may differ, but the report always needs to reflect stakeholders' requests and needs. When writing an evaluation report, clarity is critical. Tailor the document to your audience, remove unnecessary jargon, and anticipate questions. The goal is for both technical and non-technical readers to understand the findings and take action based upon them. A strong evaluation report includes an executive summary, background and purpose statement, detailed description of methods, clear results, and recommendations informed by the data. These components guide readers through what you did, why you did it, and what it all means. Present data in ways that are easy to understand. Charts and graphs can make patterns more obvious and help readers quickly interpret your findings. Effective data visualization is becoming essential for communicating evaluation results clearly and persuasively. This example shows how a well-designed chart can communicate credibility, believability, and accuracy at a glance. Clean visuals and clear labeling help people interpret results more effectively than paragraphs and text alone. When it is time to present your findings, consider timing, logistics, and audience needs. Stakeholders should receive results before they reach the broader public or program participants. Participations could be oral, written, or both, and should create space for lively discussion. The whole point of evaluation is to use the results. To increase utilization, involve stakeholders from the beginning. Monitor implementation carefully. Focus on variables that can actually change, and write reports that are clear and actionable. To further encourage the use of results, make sure that your recommendations are supported by the data. Share findings in multiple formats, integrate them with other research, and rely on strong evaluation methods to build your credibility. Once your data are finalized, you can answer the evaluation questions you identified early on. Descriptive statistics can help summarize results, while inferential statistics allow you to test hypotheses and extend conclusions to larger populations. In the end, evaluation results come from applying the right mix of univariate, bivariate, and multivariate analyses. It is the evaluator's job to interpret those findings and communicate them clearly through reports so stakeholders can make informed decisions.